Hey guys, so we were going to create our methods rotate left and rotate right. Okay, so let us begin with our methods. So to rotate left, I am going to create a temporary right node. Okay, so right. So when we have to rotate left, okay, let's take the example of this diagram C1. Okay, so this is node 1 and we want to rotate this node to the left. Okay, so the temporary right node will be the node which is 2. Okay, so 2 is going to be in the place where 1 was, and 1 is going to be the left child of uh, 2. All right, and if 2 had a left child, if let's say 2 has a left child here, after rotation it will be the right child of 1. All right, just remember this. So node dot right, and the node which we were talking about just now, this one, this, if 2 had a left node, this imaginary left node, I am going to call it a the node T. Okay, so it is node dot right dot left. So that is how we are going to navigate up to this node, right? So node dot right, this is 2, and if 2 had a left node, we will go node dot right dot left. Okay, yeah. So I think we are done with our variables. Now, first step, updating the references. Okay, so we want to bring the temporary right node in the place where the original node was, right? So temporary right node dot left is going to be the node, because we made this node as temporary right node's child, left child. Okay, and node dot right is going to be the T. See here, after the rotation, 1 is the left child to the to 2. Okay, and if 2 had a left child, it would be the right child to the node 1. So I hope I am clear to you all. Now, after updation, we are going to do child to parent relationship. Okay, update. So we are going to update child to parent relationship. So to do this, we are going to create a temporary parent. Okay, and it is going to be node dot parent. Now, temporary right node dot parent is assigned as temporary parent. Now, the temporary parent which was previously the node's parent, now it's the parent of our temporary right node variable. Okay, so we have updated this child to parent relationship. Now, node dot parent is going to be temporary right node. Okay, now one more node is left, this T node. Originally originally it existed here, right? So now we have to update it and tell it that this is your parent. this node 1. Okay, so T can be a none as well as a node itself. So if T, right, we are including this T state if statement just to avoid any errors, right? It is going to be giving an error, like if, like error related to a none variable. Okay, so if T dot parent equals node, right? So this node is now the parent of T. Only if T is a true node. If it's a none or a null value, then we won't be needing these two lines. Okay. Now we are done with the updation of child to parent relationship. Now we are going to update parent to child. It's always a two-way process, right? If you are updating from child to parent, you also have to update the parent to child relationship. Okay. So if temporary node dot parent, now there are two conditions. If it is not a root node or it is a root node. So first condition, if temporary node dot parents exists, it means it is not the root node, because if it was it were a root node, there would not be any parent node, right? So now if temporary right dot parent dot left was the node itself, if the left child to the parent node was the node, then parent node dot parent dot left is going to be temporary node. So this step may be confusing to some people. What we have done in these three lines is that first we are checking the if statement, if the parent exists or not. If it does, it means we are not at the root node, right? So we updated the child to parent node relationship, but we also have to update from the parents side also. So we are telling the parent that if the node was your left child, please update it to temporary right node, right? And similarly, elif temporary node dot parent dot right node, what we are asking is here is that if the parent's node's right child was a node, then update it to temporary node itself, temporary right node itself. Okay, so now we are going to include the else block. Why else? Because we have to check if it is a root node. Okay, so if it's a root node, then self dot root equals temporary right node. Why? Just see. As 1 is the root node here. Okay. Now we are checking that if there is no parent node, as you all can see, there is no node above 1, before 1. So now we have to make this node as the root node. So this is what we have done here. This. And after updating the child to parent relationship and parent to child relationship, we have to update the height of the nodes. Okay, so first let us update node dot height, and it is going to be maximum of self dot calculate height node dot left node dot sorry self dot calculate height node dot right plus 1. So this is our formula to calculate a node's height, right? We discussed it in our previous videos. Now temporary node dot height equals again maximum self dot calculate height temporary node dot left and self dot calculate height temporary node dot right. Let us divide this into a second line, and now we have to add one to compensate for the none. Okay, now finally you can all print here that left rotation on node dot data. So this is how we are going to identify the node, right? So we are done with our rotation left. Now we have to complete the rotation right method. So this is going to be the exactly the same approach. Okay. So previously we created temporary right node. Now we are going to create temporary left node. Node dot left, and T is going to be node dot left dot right. Why? Imagine this situation. We have to rotate right, and if 2 had any node, so how we are going to traverse all the way to this imaginary node? So node dot left dot right. Okay. So now again update the references. So temporary node dot right is going to be the node, and node dot left this time is going to be T, right? And initially we did node dot right equals to T. This time we are going to do node dot left equals T. Okay. Now child to parent relationship. So temporary parent equals to node dot parent. So temporary node dot parent equals to temporary parent, and node dot parent is going to be the temporary node itself. Why? So 2 this time after the rotation 1 is the right node of 2. All right. So this is what we have done. Node dot parent equals to temporary node, and if T exists, T dot parent again it is going to be the node. All right. So we created a temporary parent variable and stored the reference to the node's parent. Now the temporary left node's parent is the temporary parent variable, and node's parent is now temporary left node, right? Now we are going to perform the parent to child relationship. So if temporary left node dot parent exists, if temporary node dot parent dot left was the node we want to update. Temporary node dot parent dot left equals to temporary node, and elif temporary node dot parent dot right was a node. So in this line what we did is, if the right node of temporary node's parent was the none, oh sorry, was node, then temporary node dot parent dot right is said to be the temporary left node. Okay, now else self dot root is going to be temporary left node. Alright, and now we can copy these lines to update uh, the heights, and now we have to make some changes. This is temporary left, 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 right notation. So yeah, I think we are done, and we have to indent these back. Okay, so we are going to test our code and define the remove method in our next video. So see you there.